The energy provided by the sun through nuclear fusion is the reason that these trees behind me here can still grow today. Nuclear fusion, in its simplest form in the sun, is when four hydrogen atoms fuse together to form a helium atom, releasing energy. But this process isn't as simple as you would think. A hydrogen atom is essentially a proton. Protons are positively charged, and we know that when we try to push two positively charged objects together, they push away from each other, similar to how like poles on a magnet repel. Atoms can fuse together once they have enough energy to overcome what's known as the Coulomb barrier, which is basically the amount of energy these atoms need to come close enough together that they fuse. Once this barrier is overcome, a strong nuclear attraction pulls these protons together. Here on Earth, we need around 100 million degrees Celsius just to overcome this barrier. But the sun does this every single day, at 15 million degrees Celsius. How is this possible? It's all thanks to quantum tunneling. To understand what this is, let's see what happens if we, the protons, try to walk over this hill, the Coulomb barrier. To get to the other side, I need to use quite a bit of energy just to get across. But thanks to our friend quantum mechanics, I can go right through this hill and continue nuclear fusion. How? The secret lies within how we view our protons. The truth is, we don't really know where our protons are. But what we do know is the probability of where it can be, which can be represented using this wave function, and our proton can be anywhere within this wave. If we represented our proton inside of a box, this wave here would show where our proton could be. There's a very high chance of the proton being inside of the box, but there's also a very small non-zero chance that it can go outside of the box. When two of these boxes get very close to each other, the protons could appear outside of their boxes and fuse by skipping the Coulomb barrier. But how can our sun constantly do this? Our sun is very big. In fact, it's made up of nearly 10 to the 57 particles, and with protons moving at a speed of nearly 500 kilometers per second, there's plenty of opportunities to get close. So the next time you wonder how the plants around you grow, you can thank nuclear fusion.